first off, thank you for attending this webinar today. We are excited to have you with us for the next 45 minutes or so. Angelita is an incredible person. I'm so glad she was able to join us. We'll get a chance to introduce ourselves here in a second. So let's go ahead and get into the meat of the content. Of course, as we already briefly introduced ourselves, I'm Adam Tank. I'm with Transcend Software, and this is Dr. Angela Maria Fastnacht, affectionately known as Angelita to those who know her well. So I will refer to her as Angelita during the course of this webinar. And today we want to set a brief outline for what you can expect. So many of you, I assume all of you, have some interest in PFAS and PFAS treatment and the new regulations that have come out specifically in the United States around PFAS. And the whole challenge right now is that there's a lot of uncertainty when it comes to PFAS. There's uncertainty around how we treat for it, how we measure it, when we need to be in compliance, and it's leaving utilities and engineering consultants and equipment suppliers with a lot more questions than there are answers. So today what we want to do is help you uncover a bit more about how you can get answers to some of those questions that you desperately need. How much will it cost to treat for it? How long might it take? How do we think about assessing different options for treating PFAS? And in particular, we're going to talk about how utilities and equipment suppliers and consulting firms are using software to do exactly that. The other thing that you're going to see is a real live demonstration of the treatment software. So we're going to run a demonstration project. And during the course of it, Angelita and I will be exchanging words about not only the tool, but what's happening in the industry. And as I mentioned, she's a wonderful human. She's also extremely knowledgeable about PFAS. So do not hesitate to ask questions in the chat today. We hopefully can get to all of them, but she is here for you to learn from, for you to ask questions of her. And of course, she's happy to answer as much as she possibly can in the short time that we have. So with that said, Angelita, tell us a bit about yourself.
Thank you. It's a pleasure to be here. Thank you for having me and WEF for this opportunity. Let me take you on a quick journey through how I became involved in PFAS treatment and what led me to partner with Transcend. Over the years, I've worked closely with global water utilities, striving to improve treatment efficiencies and environmental sustainability. I'm Colombian, and I know a few other Colombians who probably are in this call are listening to this. I'm a civil engineer with a master's in public health from Emory University and a PhD in environmental engineering from Drexel University. I'm currently a fellow at Princeton University. After working in industry in Colombia, both in consulting and government, I moved to the US, where I continued in government, consulting, and international development. I've been a board member of Global Water Alliance, which you can see here in this picture, and later transitioned to investor-owned utilities like American Water, Suez, and Veolia. My journey has taken me from engineering, design to operations, where I've led engineering departments across North America. I've worked on everything from water projects in developing regions to complex solutions in what we call the developed world, although I would say that is debatable. So that's a bit about me.
Wonderful. We certainly have a lot of work to do in the developed places, without a doubt. And the PFAS regulations certainly are layering on another set of complexities to think about as we think about water, wastewater treatment over time. So that being said, Transcend is a software company. I'm a co-founder at the business, and we are on a mission to help engineering consultants, utilities, and equipment suppliers design treatment systems and plan and assess multiple options when they're doing this work. And the way we do that is with a generative design software we call a Transcend Design Generator, also known as TDG. Our company now, it's almost shocking for me to say, we have 130 people. We have designs that have been run in over 70 countries. We've impacted over 260 million people to date for individuals who have been impacted by designs run in our software. So that's people that now have access to clean water, treated wastewater, or renewable sources of power. And we work with some of the world's leading firms. So some of you may be from some of these firms. So the Brown and Caldwell's, Arcadis's, Xylem's, the utilities like Severn Trent in the UK, sort of all over the board. And we take the learnings that we have from each of our customers and we try to educate different markets about what they're doing. So in this case, even if you aren't in the US where the regulations have just recently come about, you may be somewhere else in the world where those regulations might be coming. Maybe they won't be on the water side, maybe they'll be on the wastewater side. But in any case, our ability to work with all of the major players in a water and wastewater project enable us to help you figure out how to tackle some of these challenges because we're learning from everyone. So relative to the PFAS challenges, Angelita, anything you wanted to say specifically about these three segments?
Of course, the reason I like this advanced software is because Transcend Design Generator, TDG, that's I'm going to go for abbreviations, really can enhance the capital planning efforts. It will reduce operational costs and would create sustainable treatment operations. This tool is perfect solution for the new EPA rule. So for those of you, probably everybody knows the rule, but the EPA set maximum contaminant level for MCLs or MCLs for PFAS, PFOA, for PFOS, 4 parts per trillion. We do have another hazard index approach also for other PFAS, PFAS-XS, PFNA, PFBS, GenX, and so on, so on. So basically, the rule gives water systems up to 3 years to comply. By 2027, EPA's new regulation will be fully enforceable as of for public notifications requirements. And 2029 is when we have to complete all remediation for drinking water, offering a stronger protection at utilities. So the tool really is allowing us to resolve a lot of questions like what are some ways that we can rapidly figure out what to do, or what are the risks that we are experiencing, how much would it cost us, how long it's going to take. So the challenges of designing PFAS treatment systems today are very, very complex. And for these fast regulations, we need flexible decision-making processes. But time and budget constraints are often a limit for these efforts. For instance, for asset owners, they want error-free, detailed proposals. For OEMs and distributors, they are bottlenecks in delivering technical documentation within tight timelines. With the new PFAS rule, utilities are under significant pressure to act quickly. Although many utilities had already prepared, knowing these regulations were coming ahead, some states even had stronger rules before, there is still a critical need for fast, flexible solutions. And this is especially important for making preliminary decisions, this tool, before moving into a more robust final designs. So that's why I'm really very excited to see the Transcend Design Generator to serve as a predictive resource, enabling all these players to evaluate preliminary designs and streamline their decision-making process. This will help not only for permitting, but also for manufacturing and engineering. An example of that is vessel manufacturers and carbon suppliers can now offer more compelling bids to clients by visualizing potential solutions, rather than relying on complex traditional design methods. Engineering consultants, too, can take advantage of this software because they could deliver faster, more accurate results, opening up new business opportunities in response to the PFAS rule. So all in all, it really is helping everyone in the industry. And one last thing that will be helpful too, it is when making decisions regarding CapEx and OpEx, energy consumption or material quantities. Those things are going to come down the road.
That is a great overview of some of the benefits of the software, and I'm hopeful that this audience that we have today is a good mix of equipment suppliers and asset owners and engineering services providers. In any case, the software is built for all of those different segments. So each one of you are able to use this software in order to, as Angelita said, minimize risk on projects, be more proactive in your capital planning and your design efforts, and ultimately get it done. I'm not going to say instantly, but you're going to see quite quickly today as we do a demonstration of the software. So these processes that Angelita is talking about can oftentimes take months, if not years, thinking through what site is best, what land should I carve off in order to put more capacity for treatment systems on site? How much will it cost? How long will it take? These are not typically quick decision-making processes, but When you have a software that can do a lot of this work on your behalf and do it quite quickly, then of course that changes and projects tend to get done much faster, and ultimately everyone becomes in compliance much faster, and we protect the health and safety of the people who drink water, which is everyone on this planet. So let's go ahead and get into the software, and we'll start by running a sample project. So when you log into the Transcend Design Generator, we have a number of features available to people. So I mentioned wastewater treatment. We have, of course, drinking water treatment or PFAS related treatment. We've also entered the power industry with electric substations. And then we have something called a tool shed, which are sort of bespoke engineering applications. So things like fractionation in wastewater, wind farm calculations, all sorts of different things. But today, of course, we're going to focus specifically on drinking water. So we'll go ahead and start playing, walking through the demo today. So when you click drinking water, we're going to start a new project. And the very first thing we need to do is outline who this project is for, what's it all about. So in this case, of course, we're going to be focused on PFAS related treatment, and we'll keep our project name as PFAS because that's what's on topic. You can select between metric and imperial, so many of our users are all over the place. And you can also select what the project is for. So for many engineering consultants, this is important when it comes to billing time and material to specific projects. Now on location, you have the ability to select a location, and I want Angelita to speak very quickly about why that might be important for certain users.
It is important because if you're having a single state where you have presence, you really don't need to see any other states, and then that will help to preset and go straight to the tab or the project that you care for. Or if you have regions and areas of focus, that will be a very helpful tool too.
So once the software now understands the site, or I'm sorry, the location, and of course you're able to select a site or not, we then get into specific preferences around the water type. So groundwater, surface water, treatment type, etc. In this case, of course, we're not just treating any water, we're treating water that has PFAS in it. And so in this case, there are two options available to treat for PFAS. And both of those options, in this case, are granular activated carbon and ion exchange. So if you're looking to compare those two technologies to one another for your particular project, you're able to find out very quickly what are the advantages or disadvantages of each one. Angelita, anything you wanted to say on that?
Sure. So in this case, as you can see, you are going to say, we can compare these comparables between GAC and ion exchange can happen. You could run one set with GAC, you can run another set of these with ion exchange, and then have the comparatives at the end. That's how it will work. And indeed, it will work for groundwater, surface water, finished water, whatever type of water you want to treat.
So once you've selected the treatment technology that you're looking to utilize, there's a couple other things, of course, that we need to outline for the software. So in this case, we're creating a greenfield site, but there is the capability for the software to design on a brownfield site, so somewhere with existing assets. We don't have time to show that today. It takes a bit longer. You have to mark the site and label some of the assets. So you're seeing greenfield today, but we can do brownfield projects. And then, of course, now we need to tell the software, well, what does the water look like coming in? What is the makeup of that water that we are attempting to treat? And so in this case, we have typical water quality parameters, pH, total organic carbon, alkalinity, etc. There's little tool tips there for people so they don't make poor decisions like me, who's not a water or wastewater engineer. You try not to make mistakes and you make sure that the data is quality, so junk in, junk out. We try to prevent that sort of garbage in, garbage out scenario. And in particular, obviously they're PFOA, PFAS, PFNAs, but we have this advanced tab. So for users that are looking to do a lot more detail in terms of the level of the water that they're treating, there is the ability to add in a lot more parameters. So maybe Angelita, you want to talk to that as we walk through those a bit.
Sure. So after setting your PFAS levels, and actually you could set them based on the of what you want to remove. So do you want to set them up as removal rate? Do they want to be set up as specific concentration target? That's a little bit more advanced, if however way you want to do it. Then there are other type of parameters that are important to take on, like TOC, iron and manganese, And this is important because they could compete with the absorption process. And so knowing those, if you have that information will be critical to be able to get a better design at the end.
And I like to mention that, not all of these are required fields. So in the advanced tab, as Angelita mentioned, you'll get a much better design if you have that information. But in many cases, we don't. We either haven't tested for it, or we haven't measured it, or we might have an idea about what the measurement is, but we're not exactly certain. You can put that data in, or you don't have to, and the software will run regardless. But what you see on this screen is that there are some fields that are required. And so in particular, if you want to treat for PFAS, we need to know how much of a particular constituent there is. And the software is smart enough to know, hey, you didn't put something in here. And we need that in order to run a good, high quality design. And so in this case, we'll sort of walk through this here in a second, but you'll start to get these red errors saying, hey, you forgot to put something in here. It needs to look like this, or needs to be between this measurement and this measurement. And so that way, again, it prevents people from putting poor quality data into the software in the first place, so that you ensure the quality of the design when it comes out on the back end. So we show you what that looks like here. So as we add in certain parameters, and like I mentioned, we highlight exactly what's wrong, quote unquote, with what we've done today, which is that we haven't put in any data specific to that. You can also choose the measurement type. So whether that's micrograms per liter, et cetera, that's all in there. And then we get onto the tab for removal rates. So Angelita mentioned it briefly now, but you might want to say something a little more on that.
Yes, we can set removal rates, which is where users can experiment with different outcomes. So for example, you could try an 85% removal rate for one scenario and 95% for another. The tool will recalculate the design outputs based on these changes, allowing you to optimize for the best outcome and not making decisions just without being blind, basically, whether that's for energy consumption, vessel size, or even site footprint. So that's super important.
All right. So again, we have that tooltip that says the typical removal rate is between a certain level and a certain level. As Angelita mentioned, you can play around with it. That's sort of the beauty of the software. And then we move into the flow tab. So then we, of course, have basically what's the volume of water that we are looking to treat relative to PFAS. And so there are a few required fields. You can see those in red with the little stars. So flow rate, average flow rates. You can change between MGD and liters per second and all kinds of other data depending on where you are in the world or how you like to assess projects. And then now we go into specifics around the vessels. So Angelita, anything you wanted to talk about here?
Yes. So regarding the equipment, there are several parameters that are needed to be able to do those calculations. So the empty bed contact time is an important parameter to consider. The leak lag configurations, that needs to be defined. Some states have a minimum empty bed contact time that is a preference. And so like, for instance, 20 minutes, you will have to put those in there. That will impact the size of the vessels and also will impact the type of vessel they're going to use for the preliminary process flow diagram.
Of course, if you are a vendor of these treatment technologies, you may have specific inputs that you would like to see for your treatment technology. Those can all be configured, and we do that for specific vendors. So whether that's the size of a tank or the material of the tank or the cost of the tank, these are different things that can be configured based on the scenario. But for this demonstration, you're seeing a sort of a high level idea of what the software can do, sort of quote unquote off the shelf. And for most utilities or asset owners and even engineering consultants, this gives you a very quick and trustworthy answer to get you to the point where you can start to make decisions. And then maybe you go to specific vendors and say, hey, here's the amount of land I have available. Here's what I think it's going to look like. And here's roughly, the costs I have associated with it, but give me some more of your specifics. I now know I want to do granular activated sludge or ion exchange. Yes. Then you can then go out to those vendors and figure out, more specifics. All right, so there's a few other inputs here that are configurable. Again, the software has already pre-populated some of these. So in this case, Disposal site has a direct impact on operational costs. So you can put in the miles or kilometers away. You can fill in that detail or not. The software will make some basic assumptions. And then, of course, we have some other preferences. So if you're thinking about the inlet pressures and any additional pumps that you might need per skid, those types of things, those are able to be configured in here as well. Finally, then we get to the costs aspect. So as we think about these projects and the uncertainty around how much it's going to cost from both a CapEx and an OpEx point of view, the software will give you a quick answer to either activated carbon or ion exchange, which is one of the biggest questions most utilities in particular have when it comes to these projects. Annalita, anything on CapEx in particular?
Well, one thing that I would say is that because you have the ability of playing around the different type of removals or vessel types, or, there are many things that you can really create what if scenarios. It helps to be able to set, for instance, calculations and think through the 5-year capital plan, for instance. I know some of you may have not just one site that needs to be remediated, maybe many, and those cannot happen right away. And so that really is a good tool that can help forecast and set some of these costs associated to that removal, not for right away making it, but to put them into the 5-year CIP.
So we'll look through some of the rest of these. So in this case, the CapEx cost assumption, and this would be in US dollars, but again, depending on where you are in the world, that can be configured as well. And then of course you have your operational expense estimates. So these are sort of standard industry standard estimates that are well known, but of course specific vendors may have specific estimates. So once you put all of this data into the software and you are ready to take a look at sort of the output side of things with a high level overview. So this screen provides you a very simple layout of what this operation might look like and specific aspects of the main process units. So if you wanted to edit anything, once you get to this final screen, you can then click on that particular process unit and go in and modify a specific aspect of that. As an example, so maybe say, I really wish I would have changed a temperature or a pressure or something along those lines. That can then be modified. And of course, it's updated instantly. So finally, we have a summary screen. You can get your output documents in either metric or imperial. And then you can do some things relative to your equipment list if you would like to. And then once you press Run Design, the software takes care of the rest. And so there's no more manual aspect to doing a treatment-related design. And you can see now it has 0 of 4 files running for the project that we just did. Now 1 of 4 files are completed. And as they update, of course, the number will tick up. So right now we'll go ahead and click into that project. And we can see that the first one that's done is a basic equipment list. And so here we have a few parts or a few pieces of equipment that are specific to this project. And this is in a PDF format, but you can also get the Excel file as a downloadable after this. And so in this case, we talk about the pressure vessels for granular activated carbon and how many of those that we're going to need. That would include things like the unit's power rating. So you're looking at the electrical load consumption to give you a better feel around the OpEx costs. While we were looking at the equipment list, the technical description was generated. So the technical description will talk a bit about how certain equipment was specified or how the calculations were created, and it will give you more data and detail around each particular process unit or each decision that the software made when it came to the project that you had run. So this is the technical description. This is a pretty long document. I think we'll see how long this one is. It might be about 40 pages or so. But this basically is what many engineers would call a preliminary engineering report. It's not as detailed as a typical PER. This is meant for conceptual design, preliminary design, so not detailed design. But it will give you all the tables and, again, those calculations and decisions that the software went through when it came to making some of these project assumptions. And then it may also have some of the user inputs here too. So in this case, you can see like the hazard index calculation is a simple example. One of the biggest questions we have is, well, what is the software actually doing to come up with decisions? This is where it's listed. This is how you know that you can trust the calculations and decisions that the software made relative to this project. Another thing to note, there's ability to modify an existing project. So as Angelita mentioned, playing around in engineering world is not something that's sort of a message that's communicated often. But that's really what the software encourages you to do, is to play around with multiple scenarios, multiple alternatives, to start to change different parameters, see how that impacts CapEx and OpEx, and be able to hone in on the solution that's the best fit for your particular project. And so again, in this case, we modified one parameter, the pH. It updated on our basic process scheme here. We press run design, and it's going to create an entirely new set of documentation. No other calculations required. So you can run effectively as many different scenarios as you want. The software will take care of the rest in the background, and it's a very, very quick process. All right, so we mentioned in the interface, when the design is done, you will get a notification that says X number of files are ready for this project. You will also get an email that lets you know that your project has been completed. So in this case, you know, this email comes through literally minutes later after running the design, and then you can go in and check your project. So if we look at then what a completed project might look like, your ability to download both PDF and editable documents. We want to create a new project in this case, a new scenario. Let me fast forward here a little bit. So once we get to the end, we have effectively played around with multiple scenarios in multiple parts of the software. Angelita, anything here?
One thing to comment is that, yes, you can do that. You still have your first project in there, so you can compare with the first project you did. But then you can make these modifications and then create a second set. So it's not that you are only producing one and that's it. You can really produce different sets and then compare them in different aspects, including, you know, your operational costs and footprint as well.
All right. So now that both designs have been completed less than 5 minutes after running the project, you then get a full output package. And so when we talk about an output package, what we mean is a technical description, an equipment list, load list, process schematics, site plans, and schedules. And they're all available in their editable formats. So an equipment list comes in both PDF and Excel. The 3D model comes in PDF, but also in Revit. So for you civil engineers that are on the call, you'd be excited to note that you can take the file that is generated and import it directly into Revit and start to manipulate those buildings or those assets on the site. And it's a very easy way to come up with again, a complete conceptual design package that gives you the data that you need to make a decision very quickly. Anything here, Annalena, you wanted to say?
No, I think you mentioned pretty much everything. You know, the software is able to give you enough tools to be able to make decisions and edit those decisions. And I would say this is a very useful tool because this particular output is something that you could easily use with your conversations. If you're a user, a project client, conversation with a client, between a consulting firm and a client, or even with conversations with your township, if you are working with a township to deliver this solution for it.
Speaking of townships, one of the things that's important when utilities are communicating with their constituents, or a utility manager is communicating with the legislators, if you will, or the folks that they're going to for rate increases, is the ability to show people what this actually will look like once it's built, once it's a part of their community. And so one of the things that I get most excited about the software is the site plans and the layouts. So not only will you get the site plan in a 2D format, sort of the top-down version. You can see the different pressure vessels here on a site. But of course, you also get the 3D version. And the 3D version then can be imported into Revit, and you can create some beautiful graphics very quickly about what this might look like. So here is an existing site with existing treatment systems. The software designs the new 2D rendering for what this might look like. Of course, the Revit file can then be used to create the 3D model. And if you are someone who is speaking to a utility about the possibilities of what your technology or your engineering firm can do for them, being able to show them before you go into the meeting that you've already generated 3D models for them, or for the utility to say to its constituents, here's the land we acquired, here's why, here's what this will look like once it's operating, you can very quickly show, here are the 3D renderings, here are the models that we're looking at, and it's a great way to communicate sort of the value of the project or the service that you are providing. So specifically, we talked about running multiple scenarios to evaluate different treatment types. In this case, again, we have granular activated carbon and ion exchange. You can see that the ion exchange has a much smaller footprint than the granular activated carbon, but of course that may not tell the whole story. Sure, it looks much nicer because you're using less of a footprint, but there's much more data that needs to be assessed in order to determine what's actually the best solution for your particular PFAS treatment challenge. And so that's where some of that data from the software comes in. So Annalita, anything you wanted to speak to relative to this?
Well, in here, you can see the comparatives between GAC and ion exchange. And I know I've noticed some of the questions at the chat regarding why you haven't included anything else other than GAC and ion exchange. One step at a time. So for now, these two are ready to start for comparatives. If you want to know more about what type of carbons or resins we are working with for these designs, happy to do that. Just we can go over that one-on-one if you would like to see it. It's not for every single one yet, but it will be ideally we can input this vendor's information into this software. The comparatives here, you can see, is a general information, not a surprise that you will get otherwise in a different type of design. Engineering design is exactly the same. You compare the two designs. They can't be run simultaneously, but they are able to be run side by side. See the comparisons as you see here. It will really be helpful to understand the real trade-offs between one technology versus the others. It will help to understand the energy consumption, as you can see, the site footprint, where are we going to compromise in this case, and the costs. There are implications of going with a larger footprint if you have areas of risk, like places where you have historical areas or places to protect. And so this is a very helpful tool to be able to see what are you compromising and what are you choosing based on the actual output before you spend the time building a 60% design, for instance, that could take probably more than 6 months.
As Angelita mentioned, we love talking to innovators in the space that have new types of technologies to remediate PFAS, and we do hope to incorporate them over time. I would say for most municipalities here in the US, you have to evaluate these two technologies just because that is sort of the tried and true method at this point. And oftentimes, spending time evaluating the tried and true doesn't leave you much time or budget to evaluate the more innovative technologies. So even if the newer technologies aren't in the software, you can take care of the basic analysis using a software like this and spend more time evaluating something more innovative or maybe something that you're more interested in or maybe not as proven, quote unquote, in that way that you can focus on building something a bit more innovative.
Exactly.
All right, so if you are heading to WEFTech this year, it's just here in a few weeks, actually, what, 2 weeks or so. We would love to see you. I will be there in the flesh, be happy to answer your questions. We will have some experts from our team as well. And then for anyone who's interested, as a member of this webinar, you were able to register for the software and run a design for free today. It is a basic version, so it's not going to be all the features, but it'll at least give you a feel for what the software is and how it works, and make sure that what we showed you today is actually the truth. You can go in and test it yourself and see how that works for you. All right, so thank you very much. We know there are some questions in the chat. Let's hope that we can answer those. And we look forward to hearing from you soon.
Sure, absolutely. Adam, can you hear me okay?
Yes.
All right, perfect. We do have several questions that are in the chat. We may not be able to get to all of them, but I will let you all know that your presenters will receive a copy of this chat as well as your contact information if they need to reach out to you. We'll begin with the very first one that I saw. You may have referenced some of these during your presentation, but if you would, just reference them again. What's the ideal size of projects you see this software benefiting the most?
Excellent question. So this software is perfect for under 40 MGD, under 50 MGDs. That's pretty much how it is. Over that, it's not that it's not able to produce it. It's just that we will say that would be a large footprint if you are going for vessels, for instance. It's able to produce, it's able to calculate it. So being more efficient, under 40 MGD, I would say.
All right, perfect. Why isn't reverse osmosis an option for treatment or possibly foam fractionation? There are also many types of GAC and IE resins available. How are these evaluated?
I like your question, Steven. I like where you're going. That's what I was making reference to. And probably similar to Jean-Claude's question regarding all UV radiations and other solutions that are in there that could help with the process of removal. Some of them may, to some extent, destruction. We have started with traditional GAC and ion exchange, just like Adam said. It is what is right now on the fingertips. People are. Our intention is not to only advertise those two technologies. Our intention has been to precisely help make quick decisions before making the final decision on how that technology will look like, not needing to go into very expensive commitments to a full design course. Let's see how that looks like while we can get other solutions in place. And ideally, yes, we would like to include other type of solutions in here. For now, again, we have these two. We will be working on others. That doesn't mean that the other ones that you mentioned are very valuable. Definitely, RO is one of the great technologies that you can see, especially for PFAS removal. And we should never be put on the side. It is just not in this tool yet.
All right, great. Why is ultraviolet radiation at 185 or 254 nm assisted with Persifate not an option? Why was this option omitted? Will this be added to your program in the future?
That goes along with what I was referring to the last question. It is not omitted in purpose. It is definitely something that we just went with the two technologies that are vastly used in the US mainly, and that doesn't mean that the other ones are not as valuable. So it could come here in the future.
Okay. Does the system consider single-use media only, regenerable IER or GAC? What about virgin GAC versus reactivated GAC?
The system only considers single-use media.
All right. On your website, it is stated that the design generator will also build equipment list for valves and instruments. If so, does the software have a built-in database of items, or does the user have to build their own database?
Adam, do you want to take this one?
Sure. There is a generic set of instrumentation for the software as it is. So that equipment list or that equipment database does exist. Of course, it is, again, generic. So we don't have a vendor-specific list of items and equipment necessarily. There are companies that we work with to incorporate their specific equipment in here. So I think about on the wastewater side as an example. If you select a DuPont Mempulse membrane as an example for the membrane bioreactor, that is going to be a DuPont Mempulse specific equipment list with a set of valve schemes and potentially even controls. So Art, to answer the question succinctly, yes, there's a generic equipment database. Yes, the user can also configure vendor-specific equipment if required, but that would be on a one-off conversation that we would have with you.
Are you intending to design the software for PFAS destruction?
That would be a question for Adam.
If you are someone who does destruction, we would love to speak to you. We have spoken to a lot of different vendors. We at some point would love to be able to incorporate destruction into this. We do not have it today, but if you are someone who plays in that space, please reach out. We are always looking to incorporate those types of technologies. I will say, we mentioned early on, we work with a lot of the world's leading global utilities and asset owners. These are people that have hundreds of treatment plants, both wastewater and drinking water or pure water, within their management or within their responsibility. And so when they go to do their capital planning and assessment, they love to see more options, because when they're running the software, they would love to see, all right, we want to check granular active GAC, ion exchange. Oh, and there's a destruction technology in here. Let's go ahead and select that too and see what it looks like. So for vendors, it's a great way to get specified in early with some of the world's biggest engineering consultants and asset owners and get your equipment out there in a very meaningful way.
What percentage of removal of PFAS can be expected with this approach? Is the notorious CF bond broken with this design?
So remember, this is a removal. So no, CF bond is not broken with this design because it's not destruction. GAC and ion exchange is removal only at this point. That goes back again to the question about PFAS destruction. The tool could be configured. I would love, and I think Adam asked for this, just put a call for action if any of the PFAS destruction technologies can reach out to Adam and discuss about it. What percent of PFAS is removed is the percent that you want to set up. So those are two ways that you can set up in the system. If you want to set up at 85% removal, you sell that up based on your interest, your budget, and the rules you have to abide by.
Okay. We are removing the PFAS from the water treatment. Where does the removed PFAS go?
That's a good question. That would be a good answer, a good question for media vendors. It stays in the media, and that's part of the next chapter. You know, as you remember in this software, there is a location where you say, what is the disposal. The software asks you the question, the disposal method. Typically, the disposal methods that exist today, traditional ones, are still holding, or the holders will make the decision where that's going to be disposed. Then utilities are charged a fee for that. That may change. But for now, the tool is asking for that for the user input. It is not necessarily for us to know where that's going to. Typically, it will stay in the media, and the media vendors will be required to do the disposal after that.
Does your software assume consistent conditions, or does it build in some variability in parameters?
That's a very, very good question, Joel. There is, at this point, the software assumes consistent conditions. However, there are ways to be able to customize to variable scenarios. And I know that goes, PFAS, for instance, can vary based on the seasonality. And so that would be something that we can help as a team to build on and then reflect those differences based on the season.
Great. I actually do not see any additional questions in the chat. That actually brings us right to the top of the hour. We actually just got one in. I'll just go ahead and do that. I believe it says Claros Technologies offers PFAS destruction for concentrated streams. I welcome an introduction. So it's just someone just kind of reaching a hand out. Again, Mr. Mahoney, we'll get this chat transcript over to our presenters so that they can reach out to you.
Excellent.
And those are all the questions. Again, that's going to bring us to the very top. I just want to remind everyone that a recording of this webcast with audio, visuals, and a link to the PDF of these slides will be posted on our landing page. We will send an email out to all of our registrants tomorrow. We thank you, our presenters, Adam and Angelita, And we also want to thank our sponsor, Transcend, for sponsoring today's WEF e-showcase. Do you all have any parting comments that you want to make before we close out?
Thank you. Please reach out. If you'll be at WEFTech, would love to see you there. But do not let that be a reason that you don't reach out if you're not going to. Email is just fine, and we'd be happy to set up time to speak to you.
Thank you
right.
so much.
Perfect. Thank you. Thank you so much. We really appreciate it. This actually concludes today's e-showcase. Thank you all for attending. The recording will be available at wefbuyersguide.wef.org. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts. Thank you, everyone.
Thank you.